All right, we're in Chapter 3, Lesson 2 today. Our books are open to page 120, and this lesson is all about algebraic expressions again, but this time we are writing expressions instead of evaluating them. Our learning target says I can write algebraic expressions. So let's go ahead and get that down. All right, looking at the top of page 120, there is a chart that is actually very important. This chart is talking about what are the different ways to say in words addition, subtraction, multiplication, and division. And unfortunately, we are going to write these down. These are really important to have in our notes because if you see these words, that'll help us determine exactly what operation to use when we're writing expressions. So in our notes, we're going to make some columns. Our first column is going to be the addition column. And I'm going to kind of chunk these so we can see the difference here. Then we're going to have the subtraction column. And then we have our multiplication column. And then we'll have our division. So just kind of separating these different ideas. So there's multiple ways of saying these things in words. So let's start with addition. One way to say that is you could say added to. Another way to say addition is just saying the word plus. Another word for addition is the sum of. Sum is the answer to an addition sentence. You could also say the words more than. Next, the one I see in the chart is increased by. That also means we're going to be adding. The next one is total of. And total, remember, doesn't always mean addition, but a lot of times it does. And the last one, if you just see the word and, it might mean we're going to be adding as well. So I'll kind of make a little dividing line here. So all of these different things are ways that we can show addition. Next, our list for subtraction. We could say subtracted from. So kind of opposite of added to, we could say subtracted from. Then we could say the word minus. We could also say the difference of. So difference is the answer to a subtraction problem. We could say less than. We could say decreased by. Fewer than. And take away. Lots of different ways to say subtraction. It's about the same, addition and subtraction. Make a little division line here so we know where this one stops and this one starts. There are less ways to say multiplication. So if we look at the chart, we could just say the words multiplied by. So that's one way to know we're multiplying. You could see the word times. Then we could say product of. Product is the answer to a multiplication question. We could say twice. Twice means we times by 2, if you want to get technical with it. And the word of. If you see that word of, if you're wanting something of another number, then we're going to be multiplying. So those are the different ways of showing multiplication. And there are even less for division. So one way to just say divided by. And you could say quotient of. The quotient is the answer to a division problem. So this is a really good chart to have in our notes. So if you see these words, that is what they represent, and it helps us when we're writing expressions because we can identify these special words. So now we've got that vocabulary in, we can go ahead and look at example 1, which is writing numerical expressions. So we're going to just start with numbers only, including our operation sign. So example 1, it says write the phrase as an expression. So we're going to put A and write out exactly what we see. It says 8 fewer than 21. So we're going to write that out. 8 fewer than 21. So the key words here are fewer than, and if we go up to our chart, fewer than is under the subtraction label. So we're going to say 8 fewer than 21. I know I'm going to be subtracting. So this is the question. I know I'm going to be subtracting 8 and 21. A lot of kids would write my 8 right here and my 21 here. However, that is not the correct way to do it, because if I want 8 fewer than 21, I have to start with my 21 and subtract 8 from it. This would give me 8 fewer than 21. So be careful when you're putting your numbers in your expression. Make sure that you don't just put them in the order that they come. So this would be 8 fewer than 21. We don't actually write the answer to this when it just asks us to write it as an expression. Question B. The expression in words says the product of 30 and 9. So we'll write that out. The product of 30 and 9. So if I'm looking at the special words here, product of, if we go back up to our list, it's multiplication. So I know I'm going to be using multiplication in this number sentence, and we want the product of 30 and 9. In this particular situation, it doesn't matter which number comes first, so we can put whichever one first that we want times the other one. So 30 multiplied by 9. Next, we're going to take a look at example 2, same page. So with example 2, it's asking us to write algebraic expressions. So we're writing the phrase as an expression again, but this time you'll notice that there are some variables. We actually don't do anything different with that than we did up here with our numbers. We follow the same process. So question A, in words it says 14 more than a number x. So we'll write that out. So underlining our keywords here. More than. More than, if we look up in our chart, is addition. So I know I'm going to be adding. Can put that down. And I've got the numbers 14 and I've got the letter x that I'm going to be adding together. So it says 14 more than a number x. So if I want to start with my x and add 14 to that, I would get 14 more than x. Now in this particular case, since we are adding, it does not matter which number actually goes first, the x or the 14. But this is how it will be written as it is said in words. Going on to question B from example 2. A number y minus 75. So I'm going to underline the word minus here. That's going to be the important information that's going to tell us we are going to be subtracting. And in this case, it says a number y minus 75. So we're going to write it exactly the same way that it says in the sentence. Y minus 75. So y, subtraction sign, and our 75. So we've got one more for this example. It says the quotient of 3 and a number z. So we're going to write that out. The quotient of 3 and a number z. So it's kind of confusing. They're talking about numbers, but they put letters. However, let's underline the important word here. It's quotient. I see the word quotient, so we're going to use, and quotient of, to be more specific, we're going to use division. So I'm going to put my division sign. And now we got to figure out which thing comes first. We're going to divide 3 and a number z. So I'm going to put 3 divided by z. So that's taking a expression in words and writing it out in numbers, symbols, and letters. If you want to pause the video and try the first 6 on your own at the bottom of 120, go ahead and try those out now. All right, so if you tried them out, here are your answers. For number 1, we should have 18 plus 35, or you could also have written 35 plus 18. Number 2, 6 times 50, or 50 times 6. Either one of those would be okay. Number 3, b subtract 25. Number 4, x divided by 4. And for those last two, it does matter which order you have those in. So it has to be the way that I said it. Number 5 could be t plus 11 or 11 plus t. And number 6 has to be this way. It has to be 100, take away or subtract k. We will go ahead now and look at page 121 and example 3, which says writing an algebraic expression. So this one has a situation for us that we'll write an expression for, but it's not just random numbers. They actually connect with something in your life. So we'll start a new page for this one so we have enough space. And we'll write example 3. All right, at the top of 121, it says, the length of Interstate 90, or I-90, from the west coast to the east coast is 153.5 miles more than 2 times the length of Interstate 15 from Southern California to northern Montana. Let M be the length of the Interstate 15. Which expression can you use to represent the length of Interstate 90? This is really a multiple choice question, but to solve it, we're going to just go ahead and write it out the correct way. So let's take out some important information. So they tell us that Interstate 90, or I-90, is 153.5 miles. 153.5 miles. And some important words there say more than, so I'm going to underline that, more than. Then they say 2 times, so that's also important, 2 times the length of Interstate 90. So I'm going to put not I-90, I-15. That's kind of the important information out of that whole chunk of stuff they give us. They also want M to represent I-15. So they're going to be using an M, a 153.5, and some symbols here that represent more than and 2 times. So if we pull out some of this, more than is representing addition. 2 times is going to be representing multiplication. So I know I'm going to have addition and multiplication. So this is 2 operations at once. And it says 153.5 miles more than 2 times the length of I-15. And if I-15 stands for M and it's 2 times M, I know that I'm going to be multiplying 2 times M, or my I-15, so 2 times M. Then we can use the more than and our 153.5 miles to finish our number sentence. So 153.5 plus 2 times the length of I-15. This will be our expression. If you wanted to shorten it up a little bit, you could. You could rearrange it too. So you could have the 2 times M in the front if you wanted to. And remember, you don't have to put the multiplication sign if it's 2 and a letter, if it's a number and a letter. And then we can add our 153.5 on the end. You could have these terms either direction, so it could look like this too. 2 times M on the back. So either one of those would be our final answer. So if we look at our choices, we're going to be picking choice A, 2m plus 153.5. And lastly, we have a real life situation here. It says you plant a cypress tree that is 10 inches tall. Each year, its height increases by 15 inches. They want us to make a little table that shows the height of the tree for 4 years. Then write an expression for the height after t years, t standing for any number of years. And then what is the height after 9 years? So let's go ahead and switch colors here. And we'll start by pulling out some of that important information and getting it down. This will be example 4. So we're talking about a cypress tree. And they tell us the cypress tree is 10 inches tall when it's planted. So it's already a little bit tall. It's not going to start at 0. And then in each year it increases by 15 inches. And I'm going to underline increases by, because if we look in our chart at the beginning of the lesson, increases by represents addition. So we know that we're going to have some kind of addition happening here. Question A asks us to make a little table. So we're going to have the years that have passed in one of the columns, or t-chart, if you will. And then we'll have the height of our little cypress tree in the other column. So we actually need to start with no years going by because the height of the cypress tree already starts at 10 inches tall. So we need to start at before any years have passed. How tall is this cypress tree? And it's 10 inches. Then after 1 year passes, it says it increased by 15 inches. So I'm going to add 15 inches to my 10 inches, and that gives me 25 inches. Then after the second year, I'm going to add another 15 inches, which is going to give me 40 inches. And in the directions, it asks us to take this table out to the first 4 years. So we're going to go 2 more. So if we add another 15 inches to this, we would have 55 inches. And then adding another 15 to 55 would give us 70 inches. So there's our table that A asks for. And B asks us to write an expression, or part of A, I guess, asks us to write an expression for the height after t years. They want us to use a t to stand for years. So if we're looking here, we're adding 15s. So I know we're going to be adding 15 to something. So we need to figure out, what am I doing with this plus 15? Well, it's 15 inches for every single year that passes. So I'm going to put my t next to this 15 because it's 15 inches for every t years. So 15 times t. Then I also have to add something right over here because the tree already starts at 10 inches tall. So I have to start with 10 inches for my tree and increase that by 15 inches every year. So 10 plus 15t is going to be my final expression. And then lastly, it says, okay, how tall is this tree going to be after 9 years? So they're basically saying if our time that has passed is 9 years, what would our expression's value be? So I can go 10 plus 15 times 9 to get that answer. So remember in PEMDAS, we multiply before we add. So 15 times 9 would give me 135. So we add those two together. Our final answer would be 145 inches tall after 9 years. And that takes us to the end of our second lesson in Chapter 3.